Hello, hi everyone. Welcome to the Student Brand. This is our Sva sir. Today we are going to discuss about electric current. Electric current, CBSE Grade 10 Physics. So in this topic we will discuss about electric current definition, SI unit of electric current, SI unit of charge, SI unit of time. After that, so we'll discuss about quantization of charge. So after that we'll discuss about electrical elements. After that we'll discuss electric circuit. After completion of that, so we'll discuss about Ohm's law. After that we will discuss about resistance and resistivity. So actually based on that one we have to do problems also. So problems also will do it related to electric current. Okay, so let's start discuss about electric current. So resistors are connected in series, resistors are connected in parallel, resistors are connected in series, resistors are connected in parallel. So about that we will discuss, and like we can say heating effect of electric current. Heating effect of electric current are also known as Joule's law of heating. Heating effect of electric current are also known as Joule's law of heating. About that point we will discuss. After that we will do practice of some problems. Okay, so related to electric current. So let's start about electric current. So SI unit of electric current. The rate of flow of charge is called I equal to Q by T. I equal to Q by T. The rate of flow of charge is called electric current. The rate of flow of charge is called electric current. Or simply we can say the flow of charge through unit cross section area per second. Flow of charge through unit cross section area per second is called electric current. SI unit of electric current is ampere. So we are writing small letters. So I'm taking small letters. That is ampere. And SI unit of charge is coulomb. And SI unit of charge is coulomb. SI unit of time is second. SI unit of time is second. 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second. 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second. That is called electric current. Understood or not? So now you can observe here. Okay. So I'm taking the conductor. So this is the conductor. So inside of the conductor, charges are moving. So can we say only 1 electron flows, current is flowing? Only 2 electrons flows, can we say current is flowing? So we can't say only 1 electron flows, we can't say current is flowing. Only 2 electrons flows, we can't say current is flowing. Only 3 electrons flows, we can't say current is flowing. There are number of charges are moving in the conductor. Number of charges are moving in the conductor. So then only we can able to say current is flowing in the conductor. Current is flowing in the conductor. I hope it is very clear. I hope it is very clear. Understood or not? So when charges are moving in the conductor only, we can say current is flowing. Okay. So those are number of charges. So 1, 2, 3, we can't say like that. So number of charges, integral multiple. Charge is a integral multiple. So that is nothing but Q equal to plus or minus NE. Q equal to plus or minus NE. Plus or minus NE I am taking. So N is the number of charges. N is the number of charges. On 1 electron, 1.6 into, on 1 electron, 1.6 into 10 power minus 19 coulomb. So on 1 electron, 1.6 into 10 power minus 19 coulomb. In 1 coulomb, so 1 by 1.6 into 10 power minus 19, then if it is goes up 1 by 1.6 into 10 power 19, 10 power 19. If you do this one, you'll get 1 by 1.6 is nothing but, so 1 coulomb, 1 by 1.6 is nothing but 0.625 into 10 power 19 electrons. So that is nothing but, so 6.25 into 10 power 18 electrons are present. Okay, so this is the number, very important. So the rate of flow of charge is called electric current. Rate of flow of charge is called electric current. SI unit of electric charge, SI unit of charge is coulomb. So SI unit of electric current is ampere. SI unit of charge is coulomb. SI unit of time is second. 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second. Okay, so they will ask in the exam, define 1 ampere of current. Define 1 ampere of current. So or define current. And simply we can say define electric current. And what is SI unit of electric current? What is SI unit of charge? SI unit of time? So all these points they will ask. Okay. So, and one more point, quantization of charge. Coming to quantization of charge, charges are moving in the conductor. Number of charges are moving in the conductor. Only one electrons flows, we can't say current is flowing. Only two electrons flows, we can't say current is flowing. There are number of charges are moving in the conductor. So then only we can say current is flowing in the conductor, right? Yes. So that's why Q equal to plus or minus Ne. On 1 electron, 1.6 into 10 power minus 19 coulomb. In 1 coulomb, 1 by 1.6 into 10 power minus 19. That you will get. So here, 1 by 1.6 into 10 power 19. If you solve 1 coulomb, 6.25 into 10 power 18 electrons are present. Understood? I hope it is very clear. So next one is electrical elements. Okay, electrical elements we'll discuss. Those are cell, battery, ammeter, cell, battery, okay. So we'll discuss about all these points. So now. First one is electrical elements. Electrical components or electrical elements or electrical components. We can take anything. Okay. So now, first one is cell. Cell is nothing but one positive terminal, one negative terminal, one positive terminal, one negative terminal cell. And coming to the second one is battery. So here this is the battery, positive terminal, negative terminal, battery. And coming to the third one is, so open switch. So if dot is not there, that is open switch. If dot is there, that is closed switch. So this is open switch. Okay, coming to the fourth one is closed switch. This is a closed switch. Understood? This is a closed switch. And coming to the next one, fifth one is, so resistor. This is a resistor. Resistor is nothing but the device which is used to oppose the electric current in the circuit. Resistor is a device which is used to oppose the electric current in the circuit. So resistance is the sixth one. So resistance is the phenomena of opposing the electric current. Resistor is the device which is used to oppose the electric current. SI unit of resistance is ohm and symbol we can say. Okay. So next one, rheostat. Rheostat is like this. This is the rheostat. So either you can draw like this or you can draw like this also. Rheostat. Understood? Either this way or this way we can write. This is the rheostat. Understood or not? And coming to the seventh one is ammeter. So we can take this ammeter, positive terminal, negative terminal. So ammeter is connected to the circuit to measure the electric current. Ammeter is used to measure the electric current that is connected in series combination. Coming to the eighth one, voltmeter. Voltmeter is a device which is used to measure the electric current that will be connected in parallel combination. And coming to the ninth one, so wire joining, this is a wire joining. 10th one, wire crossing, this is a wire crossing. And 11th one, so bulb, so we can take bulb, bulb symbol, bulb symbol. These are the electrical elements. So I'm taking this the bulb, this the bulb. Okay, so cell, battery, open switch, closed switch, resistor, rheostat, ammeter, so voltmeter, so wire joining, wire crossing, bulb. Sir, what is use of resistor? Resistor is a device. Resistor is a device which is used to oppose the electric current. So here resistor, resistance is the phenomena of resistance is the phenomena of opposing the electric current. Second one, and coming to third one, ohm is the SI unit of resistance, and the symbol is this one. Okay, symbol. So these points are very important. These points are very important. So understand. So cell, battery, open switch, closed switch. Resistor is a device which is used to oppose the electric current. Resistance is the phenomena of opposing the electric current. SI unit of resistance is ohm, and symbol we can take. Coming to rheostat. Rheostat is a device which is used to regulate the current. Regulate the current without changing the voltage source. So rheostat is a device which is used to regulate the current without changing the voltage source. Coming to the ammeter. Ammeter is a device which is used to measure the electric current. Ammeter can be used to measure the electric current. So how ammeter will be connected in series how ammeter will be connected in circuit? Ammeter will be connected in series combination. Okay, so coming to voltmeter. So what is the purpose of voltmeter? The purpose of the voltmeter is to measure potential difference. So measure potential difference. Okay, so how it will be connected? So in the circuit, so it will be connected in parallel combination. So voltmeter will be connected in parallel combination. Voltmeter will be connected in parallel combination. Understood or not? Once again, so I'll be explaining. Ammeter is a device. Ammeter is a device which is used to measure the current. Ammeter is used to measure the electric current that is connected in series combination. Coming to the voltmeter, voltmeter is a device which is used to measure the potential difference. Voltmeter is a device which is used to measure the potential difference. How voltmeter will be connected in parallel combination? Sir, I have one question. Sir, how can you so why can't we connect ammeter in parallel, voltmeter in series, sir? Sir, I have one question. Sir, you said okay, so ammeter must be connected in series, voltmeter will be connected in parallel. So what if I change? What if I interchange ammeter in parallel, voltmeter in series? So actually ammeter has some fixed reading, right? So in if appliances are connected in parallel combination, suppose if appliances are connected in or electrical components, electrical appliances are connected in parallel combination, different appliances, different electrical appliances operate at different voltage, right? At different voltage. So if you connect a ammeter in parallel combination, so more current than required limit pass through the ammeter, then what ammeter will do? So it slightly gets heated. If you connect in parallel combination, ammeter slightly gets heated because so more current will pass than required limit. There are so fixed limit. Actually, it is fixed. So like a 5 ampere, 15 ampere. So whatever it is. So according to the appliances, we are connecting. So if it is more current goes, so then it is required limit. So automatically slightly gets heated. So coming to the voltmeter. So voltmeter we are connecting parallel. So what if voltmeter connected in series? So generally voltmeter measures the difference in electrical pressure, right? Difference in electrical pressure. So one place it is high pressure, one place it will be low pressure. Then electrical pressure. Generally it will measure the difference. So in series combination, so throughout the path current is same. As an throughout the path current is same. So where it will be measured? How it will be measured? Okay, even though if you connect in series combination, voltmeter cannot show the reading. Okay, it won't show any reading because there must be some difference in electrical pressure. Then only current, then only it will measure the difference, right? So here across the resistor, if you observe, some of the current will be okay. So it will opposes, right? So resistor is nothing but, so it opposes the electric current, even electrical bulb. So what are the appliances we are taking? It has some appreciable resistance. That is the reason we call it as a resistor, right? So resistor, some appreciable resistance is there. If you connect across it, so the voltmeter measure the difference. Voltmeter will measure the difference, right? So that's why voltmeter will be connected in parallel combination, ammeter will be connected in series combination. Understood? So I hope it is very clear. So next one. Okay, so I hope it is very clear. Next. Next. Okay, so now next one we will discuss one more point, electrical circuit. So we'll discuss about electric circuit. Let's start electric circuit. Electric circuit. Electric circuit. Okay, electric circuit. So what is the meaning of electric circuit? What is the meaning of electric circuit? So normally you can see a closed and continuous path of an electric current. A closed and continuous path of an electric current is known as an electric circuit. A closed and continuous path of an electric current is known as an electric circuit. Understood or not? So I am taking this the bulb. So I am taking this the bulb. So current is flowing. So here is ammeter. Ammeter is connected in series, and then I'm connecting to the cell. Here this is the cell. Next one switch. Okay. So connecting to the switch like this. Positive terminal, negative terminal. Current is flowing. So positive, negative. So the bulb is glowing. Sir, why the bulb is glowing? Because the circuit is closed. How can you identify circuit is closed? How can you identify the circuit is closed? If the dot is there, then it is closed. If the dot is there, then it is closed. If dot is not there, it is not closed. Understood or not? If dot is there, then the circuit is closed. If the dot is there, circuit is closed. If dot is not there, then circuit is not closed, right? That is open circuit. So now it is closed circuit. And coming to the first one is conventional current. Conventional current. And the second one is electric current. Electric current. So before finding electron, proton, electric current. First one is, so before finding electron, proton, neutron, so scientists were given the definition, that is the flow of positive charges will be considered as the electric current. Okay, so if the positive charges direction from positive terminal to negative terminal, okay, so then we can say current is flowing, right? Current is flowing. The direction of the current is taken from positive terminal to negative terminal itself. After knowing electron, proton, neutron, after knowing all these, okay, so all this electron, proton, neutron, okay, so then what they identified, the flow of electron gives the electric current. The flow of electrons gives the electric current. So then they decided, so instead of changing all these terms, instead of changing all those norms, all those equation, better we will change the definition. That is, the flow of positive charges will be considered as conventional current. The flow of electrons is known as electric current. Okay, so that's why first one is conventional current, second one is electric current. Okay, flow of positive charges will be considered as conventional current. Flow of electrons is known as electric current. So, and one more here, one more point. So, positive charges will move from high potential to low potential, whereas electrons will move from low potential to high potential. Positive charges are moving from positive terminal to negative terminal. Electrons are moving from low potential to high potential, that is nothing but negative terminal to positive terminal. So here is one question, sir, will electrons flows from negative terminal to positive terminal or positive terminal to negative terminal? So in which direction the electrons will move? Okay, so the answer is electrons always move from negative terminal to positive terminal. Electrons does not move from high potential to low potential, or that is nothing but positive terminal to negative terminal. Electrons always moves from, so in the circuit, when you connect the battery, electrons moves from negative terminal to positive terminal, negative terminal to positive terminal. I hope it is very clear. High potential, positive cell has high potential, negative terminal has low potential. So electrons will move from low potential to high potential. Conventional current is nothing but, so positive charges will move from high potential to low potential. Understood or not? So this is about conventional current and electric current. Conventional current and electric current. I hope it is very clear. Understood or not? So next one, Ohm's law. So we'll discuss about Ohm's law. Ohm's law. So this is about electric circuit. Now we will discuss about Ohm's law. Ohm's law is nothing but, so the potential difference across the ends of the given metallic conductor, Ohm's law, okay, Ohm's law is that the potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it at a constant temperature. V is directly proportional to I, V equal to IR. At a constant temperature only we are taking, right? Next one, materials required. What are the materials required? The materials required are materials required. First one, 4 cells. Materials required. Yes or no? No. So here you need to observe one thing. Point number 1, materials. 4 cells, 1.5 volts of each. Okay, so each potential is 1.5 volts each. And coming to the next one is nichrome wire. So what do you mean by, so what is the meaning of nichrome wire, or why you are taking nichrome wire? Because nichrome wire is an alloy of nickel, chromium, manganese and iron metals. Nichrome wire is an alloy of, why we are taking nichrome wire? So nichrome wire is an alloy of nickel, chromium, manganese and iron metals. So that's why that length is 0.5 meter. And coming to the next one, ammeter I am taking ammeter. Okay, so next one is voltmeter, ammeter, and coming to the next one, so switch, and coming to the sixth one, connecting wires. Okay, so connecting wires. I hope it is very clear. Okay, these are the elements. Once again, 4 cells, 1.5 volts each, nichrome wire, 0.5 meter length, ammeter, voltmeter, switch, connecting wires. Okay, so next one, circuit diagram. This is circuit diagram. Circuit diagram. Okay, so this is circuit diagram. You can observe. So 4 cells. 1, 2, 3, 4. 1, 2, 3, 4. Understood? That I am connecting to the ammeter here, and the nichrome wire. This is a nichrome wire. Nichrome wire is connected to the, so here to the circuit. Nichrome wire is connected to the circuit. Okay. So now you can see this is the voltmeter. Voltmeter. Next one switch. Next one 6. So here I am taking switch key. We can also consider as a key. So here current is flowing. Current. So here we have to mention dotted lines. Sir, why you have to mention the dotted lines? What is the use of this? Actually, if you mention dotted lines means we are connecting one by one. So we are connecting one by one. So one by one we are connecting. So that's why I am drawing dotted lines. This is the current direction. Current direction. Understood or not? So that is a circuit diagram. Circuit diagram. Now procedure. Procedure. What is that procedure? First one, connect one cell. Connect one cell and note down the reading of ammeter and voltmeter. Next, connect two cells. Note down the reading of ammeter and voltmeter and repeat the process for 3 and 4. So first you have to connect one cell and note down the reading of ammeter and voltmeter. Next, connect two cells and note down the reading of ammeter and voltmeter. Repeat the process for 3 and 4 and mention the observe the values. Observe the values and mention in the tabular form given below. So I am giving table. This is the tabular column. So in this tabular column you have to mention. That is serial number, number of cells, and ammeter reading, voltmeter reading, V by I form, that is nothing but R. V by is nothing but R. Understood or not? Serial number, number of cells, 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 number of cells. So serial number of cells, current, that is ammeter reading, potential difference is voltmeter reading, V by I form. So V equal to IR, I equal to V by R. Okay, so and R equal to V by I. R equal to V by I. Understood or not? These 2 points are very, very important. So Ohm's law gives the definition of resistance. Ohm's law gives the definition of resistance. And here one more point. 1, 2, 3, 4. 1, 2, 3, 4. So I am taking here, I am taking V on y-axis, I on x-axis. The graph is linear. The graph is linear. Sir, what do you mean by the graph is linear, or what do you mean by ohmic conductors? So ohmic conductors are nothing but the conductors which obey Ohm's law. Okay. So the conductors which obey Ohm's law, those are called ohmic conductors. The conductors which does not obey Ohm's law, those are called non-ohmic conductors. Sir, what do you mean by ohmic conductors? Ohmic conductors, the conductors which obey Ohm's law, those are called ohmic conductors. The conductors which does not obey Ohm's law, those are called non-ohmic conductors. For ohmic conductors, the graph is linear. For non-ohmic conductors, the graph is curved. For ohmic conductors, the graph is linear. Okay, because sir, why the graph is linear? So point number 1, why the graph is linear? Here is the question. So here we are starting with the first cell, right? So we are connecting one cell first. So when you are connecting one cell, before connecting one cell, ammeter reading and voltmeter reading are 0. Okay, both reading shows. So ammeter reading shows 0, voltmeter reading shows 0. So when you connect to first cell, then the reading starts showing. Okay. So it depends like that 1, 2, 3, 3 like 2, 3, 4. Whenever you are correcting, whenever you keep on increasing the cells, automatically so current and potential difference also changes. So before connecting all those cells, ammeter reading is 0, voltmeter reading is also 0, right? So then the graph is linear. Yes or no? The graph is linear. Is it clear or not? That's why it is. Okay. So that's why it is. I hope it is very clear. Understood or not? So ohmic conductors are nothing but the conductors which obey Ohm's law. Those are called ohmic conductors. Non-ohmic conductors means the conductors which do not obey Ohm's law. Those are called non-ohmic conductors. Understood? Is it clear? This is about Ohm's law. Ta-da-ding, 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 ta-da-da-da-da-da-da. Ah-na-ni. So now resistance actually factor depends on resistance. Factor depends on. Okay. Now factor depends on resistance. So resistance and resistivity. So resistance is directly proportional to length of the conductor. Resistance is inversely proportional to area of the cross section. Okay. So resistance is directly proportional to L by A. R equal to rho into L by A. R equal to rho into L by A. Understood or not? So resistance is directly depends on. So directly proportional. Resistance also depends on nature of the material. Nature of the material. Understood or not? Nature of the material. Is it clear? So resistance is directly proportional to length of the conductor. Resistance is inversely proportional to area of the cross section. And here one more thing. Resistance is directly proportional to L by A. Okay. And one more point is, here you have to understand one thing. When temperature increases, resistance also increases. Okay. So there is a drift speed. So electrons moves in the conductor. When electrons are moving in the conductor, initially when temperature increases, so the movement of the electrons increases. Okay. So after that immediately one collision will hit another collision, one collision will hit another collision. It like that. The keep on bombardment takes place. Then so electrons will take more collisions. Okay. So electrons will take more collisions. Understood or not? Or electrons will hit each other. Will hit each other frequently. Okay, then what happens? Okay. Electrons will hit each other frequently. Then what happens? Electrons will not move forward. So there only collisions, there only bombardment, there only like this it will happen. Then what happens? So if temperature increases, resistance also increases. Understood or not? That's enough. And coming to the next one, resistivity. Resistivity equal to rho equal to RA by L. RA by L. So rho equal to SI unit of resistance is ohm. SI unit of area is meter square. SI unit of length is meter. So meter get cancelled. Rho equal to ohm meter. SI unit of resistivity is SI unit of resistivity is ohm meter. SI unit of resistivity is ohm meter. So resistivity depends on temperature and resistivity also depends on nature of the material. Nature of the material. Understood or not? So this is very important, very important. So be very clear with that. So definitely, so differences they will give for 2 marks, and especially this question they will give for 2 marks. And so this derivation, so derive the SI unit of resistivity or express the SI unit of resistivity or write the relation between resistance and resistivity. Okay, write the relation between resistance and resistivity and express the relation between resistance and resistivity. And one more, so write the SI unit of resistivity. And one more point, so resistance we know the phenomena of opposing the electric current in the circuit. What about resistivity? Resistivity is equal to, so the from formula itself we can get the definition. So resistivity is equal to resistance of the conductor per unit length and unit cross sectional area. So R by L into A. Okay. So we can take like this. Resistivity is equal to resistivity is equal to resistance of the conductor per unit length and unit cross sectional area. So that is resistivity. Understood or not? SI unit is very important and definitely related to these two concepts. Problems they will ask. Understood or not? And the difference is also very important. SI unit also very important. Relation between resistance and resistivity also very important. Okay. So so resistance depends on length and area of the cross section. Resistivity does not depend on length and area of the cross section. Understood? Resistance depends on temperature. Resistivity also depends on temperature. Resistance depends on nature of the material. Resistivity also depends on nature of the material. And one more question in MCQs they will ask. So they will ask one question, that is resistivity depends on physical dimensions? No. Resistivity does not depend on physical dimensions. Resistivity does not depend on length and area. So only resistance depends. Okay. So very important. Very important. Understood or not? So be very clear with that. So in the textbook they given resistivity values. Okay, so just check once those resistivity values. So just for problem solving it will be helpful once you go through that. And coming to the next one, resistors are connected in series combination and resistors are connected in parallel combination. We'll discuss about resistors are connected in series. Resistors are connected in series. Resistors are connected in series combination. Resistors are connected in series combination. Understood or not? So now we can check. So I am taking 3 resistors. Okay, one. So one, I'm taking 1 resistor, 2 resistor, 3 resistor, 3 R1, R2 and R3. So across R1 I'm connecting V1 and across R2 I'm connecting V2. Across R3 I'm connecting V3. Across R3 I'm connecting V3. Understood? So here positive terminal, negative, positive, negative, positive, negative. So this is the ammeter. This is the ammeter. Okay, so that is connected to the switch. So this is the switch. So battery here. Battery. Yes or no? This is what is that? Battery. Battery. So what is this one? Switch. Dun, 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 dun. Dun, dun, dun. Dun, 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 dun. So here throughout the circuit, you can observe throughout the circuit current is same. Throughout the circuit current is same. Current is same in series combination. Current is same in series combination. Understood or not? So Is equal to I1 equal to I2 equal to I3 equal to I. Okay, so whereas potential difference is equal to V equal to IR, V equal to IR, I equal to V by R, I equal to V by R. From Ohm's law, V equal to IR. Understood or not? From Ohm's law, V equal to IR, right? So now we can take Vs equal to V1 plus V2 plus V3. That is nothing but IRS equal to IR1 plus IR2 plus IR3. So shall I take I common? If I take I common, the remaining values are, so I am taking common, then I am taking common R1 plus R2 plus R3. R1 plus R2 plus R3. I get cancelled. Then the remaining value Rs equal to R1 plus R2 plus R3. See, if n number of resistors are connected in series combination, if n number of resistors are connected in series combination, Rs equal to Nr. Rs equal to Nr. If n number of resistors are connected in series combination, Rs equal to Nr. Understood or not? Resistors are connected in series combination. So this is the formula. If n number of resistors are connected in series combination, Rs equal to R1 plus R2 plus R3. So if n number, this is the answer. If resistors are connected in series combination, Rs equal to R1 plus R2 plus R3. I hope it is very clear. Next one. And one more question here. Which physical quantity is constant in series combination? So current is the physical quantity which is constant in series combination. Sir, I have one doubt. Sir, what is physical quantity? The quantity which can be measurable. The quantity which can be measurable is called physical quantity. So current is the physical quantity which is constant in series combination. Resistors are connected in series combination. Next one, we will discuss about resistors are connected in parallel combination. Resistors are connected in parallel combination. Let's start. Resistors are connected in parallel combination. Parallel combination. Dun, 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 dun. Dun, 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 dun. Na, 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 na. Parallel combination. Resistors are connected in parallel combination. Parallel combination. Parallel combination. So now you can observe. Okay, so now we can observe. So I'm taking 1, 1, 1, 1. Next 2, 2, 2. Next 3, 3, 3. Okay, that I'm connecting here. So this is the ammeter. Then we are connecting to the battery. Switch. Turn. Positive terminal, negative terminal. So R1, R2, R3. R1, R2, R3. So here across I'm connecting across So across R1, R2, R3, I am connecting potential difference. Okay, so through R1, I1 it is going. So through R1, I1, through R1, I1, through R2, I2, through R3, I3. So here you can observe current is dividing. Whatever the current is flowing here, that current is dividing into three parts. Current is dividing into three parts. Understood or not? So now you can observe current is dividing into three parts. From Ohm's law, V equal to IR. From Ohm's law, V equal to IR. I equal to V by R. I equal to V by R. From Ohm's law, V equal to IR. I equal to V by R. So here you can take. So current. Now you can take IP equal to. So Vs potential difference is same. Parallel combination, right? Potential difference is same. Here a potential difference I am taking. So Vp equal to V1 equal to V2 equal to V3 equal to V. Potential difference is same. Understood? That's why IP equal to I1 plus I2 plus I3. I1 plus I2 plus I3. So then we can write, so V by Rp equal to V by Rp equal to V by R1. IP, Rp, right? Here. V by Rp. Yes or no? So IP is nothing but V by Rp. Here also. So Rp R1 plus V by R2 plus V by R3. So V I am taking common. Shall I take V common? After taking V common, what is the remaining? So 1 by R1 plus 1 by R2 plus 1 by R3. So which term is cancelled? V term is cancelled here. So what is the remaining value? The remaining value is 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3. So are you understanding this point? Okay. So sir, we know that when resistors are connected in parallel combination, the final equation is 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3. But if n number of resistors are connected in parallel combination, what is that formula? If n number of resistors are connected in parallel combination, then 1 by Rp equal to n by R. 1 by Rp equal to n by R. Rp equal to R by n. Rp equal to R by n. So this is the formula. Is it clear or not? Is it clear or not? I hope it is very clear. I hope it is very clear. Okay. Is it clear? Is it clear? Let me know. Is it clear or not? Okay. So that's fine. So that is the when resistors are connected in when resistors are connected in parallel combination, when resistors are connected in parallel combination, so the formula is 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3. Okay. So that's enough. Next, heating effect of electric current or Joule's law of heating. Joule's law of heating. Now, heating effect of electric current or Joule's law of heating. So we know V equal to W by Q. From this W equal to VQ. So P equal to W by T, that is VQ by T. VQ by T. P equal to W by T. So we know the rate of flow of charge is called electric current. The rate of flow of charge is called electric current. Okay. So rate of flow of charge is called Q by T equal to I. Q by T equal to I. So that's why I'm taking P equal to V into Q by T. That is nothing but I. So P equal to VI. P equal to V. Understood or not? Now, energy is given to the conductor, that is equal to P into T. Energy is given to the conductor, that is equal to P into T. Now, so we can take, so whatever the energy is given to the conductor, that will be converted in the form of heat. In the form of heat. So that's why P equal to VI, V equal to VI into T. So we know V equal to I here. So what is the formula of potential difference? So V equal to IR, then substitute here H equal to IR into I into T. Then you will get H equal to I square RT. Heat produced in the conductor is directly proportional to square of current. Heat produced in the conductor is directly proportional to resistance. Heat produced in the conductor is directly proportional to time. So I hope it is very clear, right? So that's enough. So we'll go to the next one. Next. So next we'll discuss few problems as I mentioned. So we have to do the problems. So we'll go to, so we'll do some problems. Okay. So let's start solving few problems. Okay. Let's start. So just check this form. Just check this formula. Okay. So after knowing these formulas, okay, we'll do few problems. So very easy. The question is very simple. So here you can check. So a copper wire resistivity is given. Resistivity is given. And as the cross sectional area is given. Cross sectional area. So cross sectional area is A and resistivity rho. And here you can take length to make. So here they given resistance. Okay, so these are the points they given. So we have to find out. We have to find out the length. Okay, how to find out the length? So here you can see. So given data, given data, given data, given data. So I have to write the given data first. Given data, given data. So that is first one rho is given 1.6 into 10 power minus 8 ohm, and the area of the cross section is given, that is 20 into 10 power minus 4 centimeter square, and so resistance is given how much, 10 ohm. So here we have to check whether all units are there in one system or not. Here they given in centimeters. Remaining all are in SI system. Only here they given centimeters. So you have to check. You have to check further. First all units are there in one system or not. You have to check first. So now after that we have to go with that. That is 1 meter equal to 100 centimeter. 1 meter equal to 100 centimeter. 1 meter equal to 100 centimeter. 1 centimeter equal to 10 mm. Okay. Then 1 meter equal to 1000 mm. So can we say 1000 mm? Understood or not? 1 meter equal to 1000 mm. Then 1 meter equal to 10 power minus 10 power 3 mm. That is, so 1 mm equal to 10 power minus 3 meter. 10 power minus 3 meter. Understood? So they given centimeter only, right? So we can go with until centimeter. From here itself we can go. So 1 centimeter equal to 10 power minus 2 meter. Okay, 10 power minus 2 meter. Here 1 centimeter square they asked. So 10 power minus 2 whole square equal to meter square. Then you'll get 10 power minus 4 meter square. That is 1 centimeter square. I hope it is very clear. Right? So 1 centimeter square equal to 10 power minus 4 meter square. So keep this one. Now you can 1 centimeter square equal to 10 power minus 4 meter square. Is it clear? Same values. So after that you have to substitute again these values here. Okay. Now you can check here. So we know the formula R equal to rho into L by A. So we have to find out, calculate the length. So length you have to find out. So length we have to find out from this. So R equal to rho into L by A. L equal to RA by rho. RA by rho. So R equal to how much? So now you will substitute here A equal to pi R square. A equal to pi R square. So here anyway A given, right? So directly you can substitute here. So L equal to 10 into area already given. So 20 into, but 20 into 10 power minus 4 into 10 power minus 4 by resistivity is how much? 1.6 into 10 power minus 8. Okay. So length we are finding, right? Length we are finding. So then L equal to, so 200 into 10 power minus 8 by 1.6 into 10 power minus 8. Then 10 power 8 to 10 power 8 get cancelled. This will get cancelled. The remaining terms are, you can write L equal to 200 by 1.6 into 10 by 10. Then you will get L equal to 2000 by 16, that is 125 meter. Is it clear? Is it correct? So check once, is it correct or not? So check once. Is it correct or not? Let me know. So check once here. Check once. Next, one more problem. Next, one more problem. Next one, you can see aluminum wire has radius. Wire has 0.25 mm and length 75 meter. If the resistance of the wire is 10 ohm, calculate the resistivity of aluminum. Okay, so we have to find out the, so aluminum wire has radius 0.25 mm and length 75 meter. If the resistance of the wire is 10 ohm, calculate the resistivity. So can anyone solve and let me know the answer? What is resistivity? Can you solve and let me know the answer? Okay. So try to identify the given data. First. Okay, so here in this question, they given, so check whether all units are there in one system or not. Check all the units are there in one system or not. That is the first thing. Okay. After that, so you have to write the formula and substitute in that. Okay. So you'll get so okay. Let's try. Here you can see first you have to so aluminum wire has the radius. So radius is given. This is a radius. This is a radius. And the length is given. This is the length. And resistance of the wire is given. This is the resistance of the wire. And you calculate the resistivity. We have to find out the resistivity. Resistivity rho we have to find out. Okay, so check once here. And one more point. So they given in mm. They given in mm. Okay, so first you have to convert into meters. So previously I given that conversion, right? So check once that conversion, that is 1 meter equal to 100 centimeter and 1 centimeter equal to 10 mm. 10 mm. So 1 meter equal to 1000 mm. 1000 mm. So 1 mm equal to 10 power minus 3 meter. Okay, 1 mm equal to 10 power minus 3 meter. So that is very important. So now they given radius, that is the radius. First write the given data. Given data. First write the given data. Okay. So first one is length is given how much? 75 meter. So length is 75 meter. Radius is given 0.25 mm. So they given radius. How to find out resistivity? Okay, so here resistance also given 10 ohm. Resistance also given 10 ohm. Now, so we know the formula. So R equal to rho into L by A. So rho equal to RA by L. So we know A equal to pi R square. So pi equal to 3.14. 3.14 pi value. Pi value is 3.14. So we know that R square given, R square. But here they given in mm, right? So as I said, here 1 mm equal to 10 power minus 3. 10 power minus 3 meters. So R equal to 0.25 into 10 power minus 3 meter. So we can take here two zeros are there. 25 into 10 power minus 5, or directly, instead of writing directly, I will write one more step. Then you will get the clarity. So I am writing 25 into 10 power minus 2 into 10 power minus 3 meter. So 25 into 10 power minus 5 meter. Then so R equal to 25 into 10 power minus 5 meter. Understood or not? So that is a radius. That is a radius given. Okay. So now we have to substitute here. Now final radius R equal to, so 25 into 10 power minus 5 meter. So this you can substitute directly because pi R square we can write, right? Pi R square, right? Yes. Now here you can observe. Here you can observe now. So I am taking, so R equal to rho into L by A, rho equal to RA by L, that is nothing but R into pi R square by L. So pi equal to 3.14. Okay, so rho equal to, so RA how much? 10 ohm. And so pi R square is 3.14. And R square is how much? 25 into 10 power minus 5 whole square by, so L equal to how much? 75. Okay, so if you do this one, You'll get the answer 2.61 into 10 power minus 6. 10 power minus 8 or 10 power minus 6. How much you'll get the answer? So row value. Anyone knows the answer? Row value. Let me know the answer. So row value. Just first check. So answer is 2.61 into 10 power minus 8 ohm meter. Answer is 2. Resistivity is very simple, ma. So we have to check the formula. Resistivity and resistance. Very easy only. Identify where it is exactly, either it is in problem or it is in concept. So where exactly you are lagging, you have to understand and do that. Okay, so related to problems, we have to focus related to problems. So here 2.61 into 10 power minus 8 ohm meter. Is it correct answer or not? Check once. You can check. So 2.61 into 10 power minus 8 ohm meter. Is it correct or not? Answer. So check once. So I'll go to the next question. Shall we go to the next one? So next question I'll write. Try to solve it. So very simple only. Very easy. Okay. So next question. Are you all ready for next question? Ooh. So it's very So here it is very simple, ma, this question. So first you need to understand, so what is a given data. So many times I mentioned in the class. Okay. So first you have to identify the given data. Understood or not? So what is the given data here? Point number 1. So current is given. Current is I. So next one, here resistance. So electrical lamp and conductor. So resistance of the conductor is given. So here potential difference is given V. Now resistance of the electrical lamp. So RL we have to find out. That is the question, right? So for that you have to check. So first write I equal to given data, given data, given data. Okay. First I equal to 500 milliampere, 500 milliampere, and so this is the RC is given, RC equal to 10 ohm, and potential difference is 6 volts. So we have to find out RL, right? From Ohm's law V equal to IR. From Ohm's law V equal to IR. From Ohm's law V equal to IR. Understood or not? So V is given R here. So R we have to take RC plus RL. So RC is given how much? 10. RC is 10. So RL we have to substitute. Then substitute the values here. The 6 ohm, 6 volts. And the current how much? 5. And here one more point. Current is given. So 1 milliampere equal to 1 milliampere equal to 1 milliampere equal to 10 power minus 3 ampere. 1 microampere equal to 10 power minus 6. Okay, 1 milliampere equal to 10 power minus 3. 1 microampere equal to 10 power minus 6. Okay, so now we can substitute here 500 into 10 power 500 into 10 power minus 3 into RL plus 10. RC already 10, we know that. RC. Then, so if it is goes down 6 by 500 into 10 power minus 3, that is RL plus 10. Then if it is goes 6000 by 500 equal to RL plus 10. Okay, so we can cancel 2 zeros here, 2 zeros there. 2 zeros, 2 zeros. So 6, 12 yeah. Then 12 equal to RL plus 10. Then RL equal to 12 minus 10. That is RL equal to 2 ohm. This is the answer. Is it correct or not? Check once. Is it correct? You know, if it is correct, let me know. Is it correct or not? Okay. So, thank you so much for joining and attending and listening the class. Thank you so much. We'll see in the next class with different problems with so next class will be now around 9:30 or 10. Again 9:30 to 10. So between that again class will be there. Attend to the class. Thank you.